We are witnessing a fundamental shift in robotics. I mean, a really big one. And the engine behind it all is the very same generative AI that powers tools you've probably used, like ChatGPT. But look, this isn't just about making robots a little smarter. This is about giving them the ability to learn, to adapt, and to finally operate in our messy, unpredictable world in ways that, until now, have been pure science fiction. But that begs a really important question, right? We've all seen those incredible videos of robots doing backflips or dancing with perfect rhythm. So with all these advances, why do most of them still, completely freeze up when they run into a simple, unexpected obstacle? How is it that a robot that can build a car with pinpoint precision can be totally stumped if just one single part is slightly out of place? Okay, so this matrix right here, this gets to the absolute heart of the problem. Your traditional robots, they are kings of that bottom left box, the known knowns. These are the predictable, repetitive tasks in a perfectly controlled setting. But our world, the real world, it lives up in that top right corner, the unknown unknowns, the curveballs, the complete surprises you could never anticipate. And that is where robots have always failed. Because think about it, you can't write a line of code for a problem you don't even know exists. The whole goal now is to build robots that can handle this entire map. The best way to wrap your head around this shift is to just think about your phone. The first cell phones were basically hardware-centric. What you bought is what you got, period. But your smartphone today, it's software-defined. New apps and updates are constantly changing what it can do. We're seeing the same exact revolution with cars, and now it's robotics' turn. It's the software, right? That's the secret sauce that unlocks real adaptability. So, what's the magic ingredient? What is the spark that lets a robot become a truly software-defined adaptive system? Well, it's generative AI. This is the engine that's finally allowing robots to break free from rigid programming and actually start to, think on their feet. And let's be super clear about what we mean by adaptive. This isn't just a machine with millions of pre-programmed if this, then that statements. We're talking about a system that can fundamentally change its own behavior in real time as the world around it changes. It's the difference between executing a script and actually learning and evolving. So how in the world does generative AI actually pull this off? Well, you can kind of think of it like a three-layer cake. Down at the bottom, you have the foundation layer. This thing is like a dream machine for the robot, cooking up massive amounts of synthetic data, situations the robot has never actually seen before, to train on. Then, the intermediate layer helps the robot understand what's going on, generating language or code to break a big, complex task down into simple, manageable steps. And finally, at the very top, the policy layer generates the final, precise physical actions, the exact way to grasp an object, the perfect turn, the right movement to get the job done. And behind all of this, you've got this incredible toolkit of different AI models. You have GANs, which are wild. It's like an artist and a critic locked in a room, constantly battling each other to create perfectly realistic data. You have VAEs, which are amazing at imagining totally new possibilities based on what they've already learned. And then you get diffusion and autoregressive models. These guys are absolute wizards at generating sequences, building a solution piece by piece, a lot like how a language model writes a sentence, one word at a time. And look, this is not just some far-off theory or a cool lab experiment. This is happening right now in the real world. And the results we're seeing, from the warehouse to the factory floor, are genuinely astounding. I mean, just get a load of this number. 50%. That is the reduction in task completion times that Agility Robotics got just by plugging generative AI into its systems. That's not a small bump. That is a massive, game-changing leap in what's possible. And it is not a one-off thing. We are seeing this across the board. NVIDIA's platforms, they're seeing robots get tasks done 40% faster. You've got Boston Dynamics reporting a 30% jump in efficiency. Agility isn't just faster, they're seeing 20% fewer errors. And over in manufacturing, ABB is boosting efficiency and literally cutting down on waste. The momentum here is absolutely undeniable. But, and this is a really big but, all of this incredible progress comes with a very serious and frankly unavoidable set of questions. When you give a machine the power to adapt and make its own decisions, who is responsible when those decisions go wrong? Because with this new adaptive power, we are also creating a completely new class of risk. Every revolution has a cost, and we have to be honest about what that cost might be. And that really gets to the core issue. Who's to blame? When an adaptive system makes a fatal mistake,
that whole chain of responsibility just shatters. Is it the AI developer's fault, the company that made the vehicle, or the human who was just supposed to be monitoring it? Our entire legal system just wasn't built for a question like that. And believe me, these are not just what-if scenarios. We have real-world tragic examples. Take accountability. The awful Uber case where a self-driving car's sensors simply failed to identify a pedestrian. Or bias. We've seen Tesla autopilot crashes where the system struggled to recognize things like large trucks. There's flawed decision-making, like in military drone strikes that have mistakenly targeted civilians. And then there's even privacy. I mean, are we ready for delivery drones with cameras that could be recording everything in our neighborhoods? Okay, so we've got these incredible benefits on one side and these really deep, profound risks on the other. Where do we go from here? How do we even begin to design a future where we can actually trust these adaptive systems?
So, one of the most promising ideas on the table is something called a digital twin. Basically, it's a perfect virtual replica of the robot and its entire workspace, pulling in data from all over the system. As you can see here, this lets the AI run simulations and test out its plans in a totally safe virtual world first. But the most important part, it keeps a human in the loop, an operator who can actually see the AI's reasoning and then give it the green light before anything happens in the real world.
And building on that idea, we need to implement 3 absolutely essential safeguards. First up, security. I mean, if these systems can be hacked, the consequences could be catastrophic. Second, guardrails. We have to set hard boundaries so a system can't just adapt itself into doing something malicious or unintended. And finally, governance. We need clear policies and constant human monitoring to make sure these systems are behaving exactly as intended, with a person always having the final say. So here we are. Generative AI is finally giving robots the keys to our complex, ever-changing world. It's giving them the ability to adapt to us. But that presents us with an equally important challenge. It's no longer just about programming them. It's about building the frameworks, the ethics, and the oversight for a world that we're all going to share with them. So the real question is no longer about the robots, it's about us. How will we choose to adapt?